So we have seen some of the important phenomena of light, and among them one of the important is the total internal reflection. There are some applications of total internal reflection. The very first one is the mirage. You might have been very much familiar with this phenomenon. Let us analyze it scientifically. So the refractive index of a medium has dependence on the optical density of the medium, that is, it is directly proportional to the optical density of the medium. As optical density of the medium increases, the refractive index increases, and it is inversely proportional to the speed of light in the medium. Now on the summer days, the air just above the ground will be hotter, and therefore the density will be less. So as the height from the ground increases, the air becomes less hotter and the density will be higher. So there is a difference in the density of the air formed above the ground as the height increases. It is because the different layers of air above the ground will be at different temperature, and that causes difference in the density. So the light ray from an object passing through these different layers of air with different densities undergoes total internal reflection. As it is passing from air with high density to air with low density, it undergoes total internal reflection as the angle of incidence goes beyond the critical angle, and the light ray that is undergoing total internal reflection reaches the observer. As you can see in the diagram, the light ray from an object undergoes total internal reflection and reaches the observer, and this light ray appears to the observer as coming from some object on ground like that of a water source, and this phenomenon is called mirage. Mirage is a naturally occurring optical phenomenon in which a displaced image of distant object is produced. Now the next application is the brilliance of diamond or the sparkling of diamond. The critical angle of a diamond air interface is 24.4 degree, which is very much small. So the light entering the diamond is likely to undergo total internal reflection, and the particular structure of the diamond, that is the cutting of a diamond, is in such a way that multiple total internal reflection occurs when light enters the diamond, and this causes the sparkling of diamond or the brilliance of diamond. The next application of total internal reflection is the image formation from a prism. So prisms are designed in such a way that the light can bend by 90 degree or 180 degree, and these prisms can give the image of the object by inverting it by 90 degree or 180 degree respectively. So here the first prism is placed in such a way that it gives the image which is inverted by 90 degree. As you can see, two rays from the object, here the arrow mark is the object. The two rays from the object passes through the prism and it undergoes total internal reflection, and we get an image which is inverted by 90 degree. Similarly, when we arrange the prism in such a way and we observe the image formed by the object, the two light rays from the object again undergoes total internal reflection, and we obtain an image which is 180 degree inverted. The next application is the optical fibers. In optical fibers, the total internal reflection of the light signals or of the electrical signals is used. Optical fibers are the effective mode of transmission from which we can transmit the signals without any energy loss. So optical fibers are fabricated using high quality glass or quartz, and an optical fiber consists of two parts, a core and a cladding. Core is covered by cladding, and the refractive index of core will be higher than that of the cladding. So as the signal enters from one end of the fiber, it is directed in such a way that it undergoes repeated total internal reflection, and finally comes out of the other end. As the signal entering the fiber undergoes total internal reflection, there is no loss of energy when we are getting it from the other side. Another important advantage on an application level is that the optical fibers can be bent, and even then we can obtain the signal without any loss of energy. Optical fibers are used to transmit signals, optical signals and electrical signals, and also even in decorating lamps we are using the optical fibers.